Hello, we're going to go on this video. I will go over the quiz on graphing logarithmic graph. So the direction says graph the logarithmic function completely. So we have y equals log base 5 parentheses x minus 1 plus 4. So I'm going to write down everything we know about this graph. Let's use blue. So what do we know about this graph? The base is 5. So we know it's definitely a growth. What else do we know? We know that x minus 1 is a horizontal shift of positive 1 unit to the right. And we also know that plus 4 is a vertical shift of 4 units up. Okay, so do we know anything else? Yeah, that's pretty much it. So, oh, what about our vertical asymptote? So if we're shifting it 1 unit to the right, our vertical asymptote will be at x equals positive 1. Okay, so let's start with the parent graph. The parent graph would be y equals log base 5 of x. And let's pick some points from parent graph. So let's use the x value 1. So what is the y value when the x value is 1? So it's going to be y1, which is log base 5, and then x is 1. So this is like saying if you use the conversion, this is equivalent to saying 5 to the what power gives you 1. That is 0, right? 5 raised to the 0 is 1. So that means your y value is 0. Okay. The next x value I will use is 5. Could you use 4? Yes. Could you use 3? Yes. But I really don't want to deal with decimals. You'll see y5 comes out nicely. So y5 would be log base 5 of 5. So this is equivalent to saying 5 raised to the what power gives you 5? 1, right? 5 raised to the 1 to the first power gives you 5. So your y value will be 1. Okay. And then the next x value I'm going to use is 25. Like I said, you could use 6. You could also use 7, but I'll use 25. And you'll see why. So y of 25 is log base 5 of 25. So this is like saying 5 to the what power gives you 25. It would be 5 to the second power, right? So your y value is 2. Okay, now I want to show you, like I said, you can use 6, 7, 8 as your x value. I want to show you that it is possible, but it's going to be like a decimal. And here, let's pretend I wanted to use 6. So y of 6 is going to be log base 5 of 6. Okay, so what is this conversion? How do you convert log base 5 of 6? This is equivalent to saying 5 to the what power gives you 6. So is that even possible? 5 to a certain power gives you 6? No, impossible, right? There's no number. So what you can do is, if you can't find a number, what you'll do is take the log of both sides. So on the right, this would be log of 6. And then on the left, when you're expanding and you have a exponent, that exponent goes in front of the log. So this 5 raised to the y could be expressed as y log of 5. Okay, so just know, yeah, so when you have a power and you want to when you want to expand it, you put the power in front of the log. And then go ahead and solve for y. So I have to get rid of this log 5 by dividing both sides by log 5. Okay, so you have y equals log of 6 over log of 5. Okay, so you just put that in the calculator and you'll see that you get about 1.1. Okay, so but for right now, I'm just going to use 1, 5, and 25. Okay, now this is for the parent family. Now let's do the one with the horizontal shift. So let's do y equals log base 5 of x minus 1. So I'm doing it one at a time. So this x minus 1 means a horizontal shift of 1 unit to the right, or what it really means is you add 1 to the x value of your previous coordinate. So 1 comma 0 will no longer be 1 comma 0. It would be 2 comma 0, right? You add 1 to the x value. 5 comma 1 will be 6 comma 1. 25 comma 2 will be what? 26 comma 2, right? And then let's do the final graph. So the final graph is y equals log base 4 of x minus 1 plus 4. So what this plus 4 is a vertical shift, or what it really means is you add 4 on the y coordinate of the previous point. So start with the previous points, not so 2 comma 0 will now be 2 comma 4. 6 comma 1 will now be 6 comma 5. 26 comma 2 will be 26 comma 6. Okay, so those are your 3 points, and go ahead and plot it. Because our x values are really high, I think it's best to go by fives. So this one could be like 5, this would be 10, 15, 20, 25, 30, etc. So this graph is not in scale. So now we can start graphing. So we said that our vertical asymptote is at x equals 1, so this would be 1. And then we have coordinates at 2 comma 4. Here's 2. On the y-axis, I think I will go by ones. This is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Okay, so I'm going by ones. So 2 comma 4 would be, here's 2, and here's 4. 6 comma 5 would be, here's 5, here's 6 comma 5 is here's 5, and then 6 would be right about 6 comma 5 would be right about here. 26 comma 6 is, here's 25, 26, and then 6 would be 4. Yeah, it's start to increase. So it would look roughly like this. Okay, so that's your graph. Um, it doesn't say doesn't ask you for domain and range, but what would be your domain? So our vertical asymptote is at x equals 1, so our smallest x value will be at 1 comma infinity. And my range is all real numbers. That's just how it is for it. Logarithmic, it's always all real numbers. Doesn't matter if it's a growth or decrease. And that's how you graph this with shifts and vertical shifts. Okay, I'll go ahead and pause to write down anything, and yes, I will stop here.